Alright, hey guys, I wanted to show you a little bit about some new Excel functionality in terms of frequency distribution. So I'm looking right now at question 13 on page 36. This is in chapter 2. It's about the number of defective units produced by some machine. And so what we're looking at here is this is saying for 9 hours it produced no defects, and for 6 hours it produced 1 defect per hour, and for 4 hours 2, etc., etc. So the first thing I need to know is how many hours we're actually looking at. And so to do that, all I have to do is go equals sum of the total number of hours. And I can just drag and drop here, and it will add those numbers for me. There we go. Okay, so we're looking for a 24-hour period. So what we want to know is what was the average number of defects the machine produced over this 24 hours. And so the way to do that, if you look in your book, will be to multiply 9 times 0, 6 times 1, 4 times 2, 3 times 3, 2 times 4, and then divide by 24. Fortunately, Excel has a function that will do that for us called sum product. And what sum product does is it says take one set of data, so this is my x, and then another set of data, my f of x, and it's going to multiply these numbers across just like I previously described and produce the total number of defects. Now since I want an average, I also have to divide by how many hours I have total. So I click B7 there, and that's 24. And then, didn't like that at all for some reason. 2 to A6, B2 to B6. All right. Yeah, there we go. So good enough. And then next, we want to compute the variance. So we need to know for each x we found, how much did it add to the variance? And so notice the formula is x minus mu. Mu is our mean, squared. And so my mean is down there. So I'm going to set up equals. So my given x will be this one for this row, minus now my mean here, and then square, like so. And there we go. So each time you have 0 defects, that contributes 1.668 to your variance. But now I want to copy and paste this formula for each one. So what I actually have to do, because I'm going to be changing rows, I want my A2 to change, but I'm always going to be subtracting the same mean. So I always want it to be B9 here, and that's where the mysterious dollar signs come in. So I'm going to put A2 minus B9 in dollars so that it always subtracts this number even as I change these various numbers. So that gives me the same thing. And now if I copy this, drag down, paste, and my paste options, I actually want to paste the formulas here. So that's what I'm going to do. And there we go. So this is saying every time you have no defects, that adds 1.66 to your variance. Every time you have one defect, it's 0.08 to your variance, etc., etc. And now for the population variance, what I need to do is take each of those variances, multiply them by how many times they happened, in other words, the f of x, and then divide by the total number of hours I had. So let's see how that works. This will be equals sum product, and for my first array, I'm going to have the number of times it happened, like so, comma, the amount of variance each of those contributed, and then I have to divide by my capital N again, so I'm going to divide by the total number of hours. And there we go. My population variance is 1.7065. And then, so if you want standard deviation, that's simply the square root of variance. So that's going to be equal to, square root is SQRT in Excel. Say, all right, square root of variance, that's this cell. Hit enter, and there we go. So that's my population total number of hours, the mean number of defects per hour, and then the population variance and population standard deviation. And yeah, so that's a quick way to do the frequency distribution questions. And I will actually include a copy of this file in the resources for week 2. So hopefully you guys found that helpful, and I'll talk to you next time.